Okay, now I want to talk about something called MIDI, which you may have seen on instruments, on different devices. MIDI stands for Musical Instrument Digital Interface. This was an important development back in the early 80s when manufacturers discovered that they could send some information from keyboards to tone modules to all sorts of electronic devices to where they could communicate. So let's look at quickly an examination of what is MIDI and how is it going to be functioning for our purposes for sound design. So the early development of MIDI started, as I mentioned before, there was a company called Sequential Circuits, which made popular synthesizers back in the late 70s and early 80s. And two of the engineers, Dave Smith and Chet Wood, devised what they called a universal synthesizer interface in 1981. And by 1983, they were able to demonstrate a MIDI connection, a digital interface connection, between the Sequential Circuits Prophet 600 analog synthesizer and a Roland JP6. So these were different manufacturers, but they both had that capability on them, so the information could go from one synthesizer into the other one and trigger a device from that. So by August 1983, we then have the official release of the MIDI specification, as it's called, and almost all the manufacturers of electronic instruments started to put MIDI capability on their devices. So the MIDI command is something that we don't send full audio information. We only send a little bit of computer data that directs us toward the basic performance information. So what you will find in a MIDI stream of computer data is not the full audio information, but the simple note on and a note off. So a computer number, let's say we have a middle C that we're trying to send. A middle C in the MIDI stream data would be a number 60. So these are 8-bit numbers, and the first bit will be sort of a status byte. So we have the 7-bit number, which gives us from 0 to 127. So within that range, if we label each pitch on the keyboard, then middle C was designated as number 60. So if you want to play a middle C, what goes out the MIDI stream is just a note on of a number 60, and then some kind of velocity, how fast the key was played. So that velocity number would be between 0 and 127 again. So that information that's really the two main bits of information that are triggered when you play a keyboard and you send out a middle C as such. We also have a pitch bin, a few other devices on MIDI synthesizers. Pitch bin allows us then to obviously bend the pitch according to some preset interval amount. So that's the primary information that's being set up when you play a key. One of the other important MIDI signals is what's called continuous controller information, and that is a bit of data that is not just one bit of information going out, but is a continuous stream of MIDI data, so that we can then use that for time variant information on the performance, and we'll talk about that in just a second. So just the technical aspect, the MIDI protocol uses an 8-bit serial transmission, where, as I mentioned, the first bit is a start bit as such. It's running at 31.25 kilobaud sampling rate, which is fairly slow in today. Remember 1981, that was a pretty fast rate at the time. There's not a lot of information going across the network on the MIDI data, so it seemed to be pretty robust. Very quickly, now we've outpaced that when we're trying to stream full audio information, which has over 44,000 samples per second. Then this speed rate is probably too slow for that, obviously. So when the MIDI protocol was set up, they wanted to find a cable that would work for that. So the 5-pin MIDI cable, which I showed earlier, is one that was adopted for that, and only 3 of those pins are actually used in that. So MIDI is a connector. MIDI, you find a connector on a synthesizer. You will not find MIDI connectors on a computer. If you want to have MIDI go into a computer, you have to have some kind of external interface. So usually there's a separate box, a MIDI interface box that you can buy, very inexpensive, that would allow you to plug your MIDI connectors, cables from your synthesizers and other devices into that MIDI interface box. From there, you would go into, usually convert to a USB or FireWire or some other kind of connector into the computer. So, but you won't find a MIDI plug connector on a computer as such. The most important part of MIDI is what kind of controller do we have, because MIDI here again is just simple performance information, so manufacturers started developing different kind of ways of triggering that MIDI information. Obviously the most common type would be a keyboard like this, where we're just sending simple data to the note information to that. But there were all sorts of other manufacturers that started developing different kind of ways of capturing performance data that could be triggering MIDI performance information. One of the most popular were different kind of wind controllers. So here we have Yamaha, the WX7, which back in the early 90s developed this. This was obviously looks like a clarinet, or could be the same kind of keys for a saxophone, any kind of wind reed instrument. This instrument, you actually play into it, just like a regular instrument. There is a pressure sensitive. You're not actually playing the notes. What's happening is when you blow into this, that's a velocity sensitive trigger here, which then allows you to press keys with the correct fingering of a clarinet or saxophone. And then from that, you send a MIDI note data with velocity. So velocity is coming from the pressure of the breath, and then this is the MIDI note. So it's the same thing as a keyboard. When you're hitting a keyboard, you've got a velocity information, and you've got a note number. So that's all this was doing. But it allowed for all the wind players to trigger sounds into the MIDI configuration and to be able to play electronically. So this was probably the most sophisticated of the wind controllers that were developed earlier on. But there were other variances of that. This is another similar device made by Akai. Has similar kind of keys, and on the back you have these little things to change the octaves they're easy to do. What this one did, this controller would send MIDI data into this box, which was an analog synthesizer. So this would be connected to this analog synthesizer, and from here you could set up, design your own analog synthesis with oscillators and filters, as we've talked about before. And then on the back of this is a MIDI out connector. So from that you could send data into your computer and record it, or to other kind of boxes. So this had its own sounds built into it, where the Yamaha keyboard wind controller had no sounds built into it. You had to have some other kind of sound source. At the same time, the Casio developed this instrument, which was a very fun instrument. It's similar to these. It has pressure information coming in from the breath, and then it has pitch information, note information coming in from the keys. It has a little speaker on board, so you actually can hear the sound like a quasi-saxophone. But there is a MIDI connector out on this, which allowed you to go into the computer, and it would function just as easily as these would to be triggering MIDI data. This was designed really as kind of a toy for entertainment purposes, and was very inexpensive, but it really was a kind of a robust wind controller at the time. Now there are other kind of companies that have developed MIDI controller information that are not modeled on traditional Western musical instruments. Obviously, trying to get the Western musician to be able to operate MIDI data and to be able to control the sounds was one part of the market that when MIDI came out, they wanted to capture as MIDI musicians who were trained on instruments to be able to use that training into triggering electronic instruments. But there were other experimental devices as well. There's a company called Infusion Systems that has made a number of different kind of sensors that the body can trigger that send MIDI data. So let me just demonstrate some of theirs. This is a touch sensor, just a little pad, and it, here again, can be sending velocity information or continuous controller information and pitch number. I can assign this to whatever MIDI data structure I want. On the back of this is a little plug, which plugs into a controller here. So I plug this into here, and I can put up to 8 into this controller. It's battery operated, it's wireless, so it's Bluetooth connecting to the computer. So this way you could have sensors on the body. The person could be moving around, touching different things, moving on the body. All this information is being sent wireless into a computer, which can receive that MIDI data and then trigger the various sounds or the various effects from that. So the Infusion Systems, this is called the iCube touch sensor system. It has been used a lot in dance performance and all sorts of real-time performance. We're going to talk more about these later in the course, where we get into real-time interactive performance. They also have other kind of many kind of sensors. This is a simple turn knob, which allows us to send the continuous controller MIDI data that I mentioned before. That is often found in the time variant kind of control, which gives it very powerful. Same thing, you plug it into that device like as well. We also have, this is a pressure sensor. You stand on this, so the pressure would actually do the velocity sensitive as well. So the whole body can be used to trigger MIDI data on this. And then finally, they have a series now of what are called biosensors. The biosensors are devices that you put on the body. This is a little glove. This data glove has sensors in each finger, in the palm, in the thumb. So when you put this on, you see there are I think there are 6 different outputs on this. So you're actually triggering 6 different points. So this way you can be sending a lot of complex information from just how the hand touches on this. And this is wireless as well. They also have sensors that pick up the heart rate, that pick up brain waves, that pick up emotion sensor or skin resistance. So the idea of trying to capture the body's information. And this information is also being used in sort of biomedical research, because it's a good way to sort of monitor what's happening in the physical body. But mostly you're finding this used in experimental multimedia performances with dance or theater, and being able to trigger sounds into the musical domain by the human body as such. Later in the course, we will look at other kind of controllers, such as the Wii controller, some of the game controllers, and the Xbox Kinect is also becoming very popular, which we'll talk about a little bit later. Those don't use MIDI; they use something else called open sound control. So we'll come back to that when we get to those. One final MIDI controller. These became quite popular. This is a company called Drumcat, or CAT, and they make pad sensors. So these are here again velocity and note programmable. So each pad you can make this into, assign it to a MIDI note. That, remember, there are no sounds on these, but each of these pads could be sending a different note with velocity information and note information, which can be triggering a cymbal or a bass drum or any kind of drum set. So you don't have to go buy a drum set. You can just buy this pad, and it could be your complete drum set. Or you could assign these pads to some other kind of sound, a marimba sound or a saxophone sound or any kind of sound that you want, because MIDI is not containing sound, it contains just information about the sound. So the idea of MIDI controllers is an important part of when you're working with MIDI. You want to explore what kind of controller that you could have to best trigger that information.
The preceding program is copyrighted by Emory University.